Okay, so today we will continue our lecture about chapter 3, and I will try my best just to try not to make it very long because I don't want the lecture to be boring, and therefore we will try to finish up approximately within 1 hour. So last time we have discussed the alkyl groups, how we name the alkyl groups, how we name the long chain alkanes, for example the methane, the ethane, and so on and so forth. And today we will continue about the classification of carbon atoms. So in slide number 14 we will have the classification of carbon atoms. This classification actually help us in the study. So generally speaking, we classify carbon atoms as primary. I will write it, primary, and abbreviated by 1 with a degree on it. Do you follow me? Or secondary, and you abbreviate it by 2 with the degree, or tertiary, which is 3, and quaternary, which is 4. Now this classification, as you can see in here, it depends on the number of carbon atoms attached to the same carbon under study. For example, in here, if we have like ethane or propane, let's take CH3, CH2, CH3. As you can see, we will classify the carbon in the middle as a secondary carbon because it's connected to 2 carbon atoms, while this carbon we will classify it as a primary because it's only connected to 1 carbon. So the classification is straightforward. It depends, as I said, only on the number of the carbon atoms attached to the carbon under investigation. Is that clear? Yes, you are right. Yes, I'm recording it. Don't worry about it. So the meeting is recorded. All right. Okay, so this is about the classification of the carbon atoms, as you can see, and this is the slide which present in slide number 16. Now let's take a little bit more example. For example, let's say, let me tell you this. Write down the isomer or structural isomer of an alkane with molecular formula of C5H12. Write the structure of alkane of a formula C5H12 with only primary and tertiary carbon atoms. Suppose we want to just deal with this problem. We need to draw the structure of alkane, saturated alkane, with a formula of C5H12. Now the condition here of the isomer, because as you have seen in the previous lecture, we may draw different structural isomers of this formula, but we need the isomer which fulfill this condition, that carbons must be only primary and tertiary. Nothing. We don't want to have a secondary. In this case, we will start with the tertiary. So we will have a carbon, sorry, instead of tertiary, just write it primary first. We can go back for any other problem, but now for the primary, for the quaternary, it means I have this carbon connected to 4 other carbons. So I will have at least this situation. Do you follow me? In this case, I just got it because simply the rest here, I just fill the hydrogen, CH3, CH3, CH3. So in this formula, as you can see, in this structural formula, I will have this carbon to be quaternary and all of these carbons to be primary. Is that clear so far? Is there any question, guys, about classification of carbon atoms? Regarding the recording of the lecture, don't worry, because we are recording the lecture and I will upload it in the YouTube in different ways. Because this recording will not be as much clear as you will see it in the YouTube. Don't worry about it. All right. So this is regarding the classification of carbon atoms. The most important issue here, just to mention that the classification of any carbon or the classification of hydrogens is the same. They just write it. The classification of hydrogen atoms is the same like the carbon attached to. This is very, very important issue here. So for example, if we have, like, take another example in here, suppose we have CH3, CH, CH3, CH2, then CH3. As you can see, if I asked you how many, in this example, how many primary hydrogens, how many secondary hydrogens, how many tertiary hydrogens. So, how to do it? It's very simple. We need to see what's the classification of each carbon in this example. You can see that according to what we have studied so far, this carbon must be primary. This carbon is tertiary because it's connected to 3 atoms. This carbon again is primary. This is a secondary and this is a primary. Let's start with the primary. The primary hydrogens, this carbon, we have 1, 2, 3 carbons which are primary, which means the hydrogens attached to it must be the same classification. So we will have 9 primary hydrogens. For the secondary, we will have only 1 carbon connected to 2 hydrogens, which means we will have 2 hydrogens which are secondary. In the tertiary, we will have only 1 carbon connected to 1 hydrogen, so we will have 1 hydrogen classified as a tertiary. Is that clear? Majid, after this lecture, you will see the lab. Don't worry about it. For the section 12, it will be open after this lecture. I'm asking now, just focus on the lecture now. Is this clear how to determine the number of hydrogens of each carbon in any compound? Okay. Here it's very important. The classification of hydrogen atoms is the same, following the same classification of any carbon attached to. In other words, here, do you understand the classification of the carbons? The one who asked. Yes, okay, so this is a primary carbon. This is primary carbon. tertiary carbon, secondary carbon, primary carbon, isn't it? Now, the hydrogens attached to each carbon is the same classification. In other words, this carbon, it is primary, that means these three hydrogens, because they are attached to primary, that these three hydrogens are primary too. You follow me? The one who asked.
Yes.
Alright, the same thing applies to this carbon, because this carbon is primary, that means we have another three primary hydrogens. This carbon is primary, then we have another three primary hydrogens. Therefore, the total of primary hydrogens, we will have 9 primary hydrogens. Do you follow? Now, applies the same if you just continue for the secondary. We will have only one carbon, which is a secondary in this case. I will just circle it. This carbon is a secondary, isn't it? Which means this secondary carbon is connected to 2 hydrogens. Therefore, we will have only 2 secondary hydrogens. Now, this carbon is tertiary. We have in this compound, we have only 1 tertiary hydrogen, which means it's connected, the number of hydrogens connected to this is only 1, which means we have only 1 tertiary hydrogen. Is that clear? Is that clear? All right. Perfect. Now let's go, or let's proceed to the next slide, which is slide number 18, the naming of alkane. IUPAC nomenclature of alkanes. Yes? Any question? Any question? I really don't hear you well. Can you repeat the question, please, now?
The previous molecule, why it hasn't a quarter carbon?
The previous molecule or the previous molecule? The previous molecule has no.
That you have deleted now.
The one which I have deleted now has no quaternary carbon. It has only tertiary carbon. Again, I'm going to draw it again. So, CH3, CH, CH3, CH2, CH3. Is this the molecule what you are asking for?
Yes.
Alright, so what's your question?
Why it hasn't a quaternary carbon?
This molecule has no quaternary carbon. We didn't say that it has quaternary carbon. We said it has a tertiary.
Why it hasn't?
Where is it? Where it could be? Which one is this quaternary carbon then?
I don't know. My question is how to determine that it's quaternary or tertiary or secondary.
It just depends on the number of carbons attached to a carbon. For example, what type of carbons we have in this molecule? What type? Huh?
Again?
What type of carbons we have in this molecule? We have this carbon. What's the classification of this carbon?
Primary.
What's the classification of this carbon?
Primary.
What's the classification of this carbon?
Also primary.
Okay, so we have 3 primary carbons, right? Now, let's just move to the other one. What's the classification of this carbon?
It could be secondary or tertiary.
Why it could be? There is no could be. Science has no could be. Science just 100% certainty. Do you follow me?
Doctor, I think it depends on the position that you start.
No. What's difficult just to know this carbon? How many carbons attached to this carbon?
2.
That's it. Then it's secondary. Do you follow me? Where should be the ambiguity here? There shouldn't be any ambiguity in here. Do you follow me? This carbon is connected to 2 carbons. According to the classification, we said classification of the carbons depends on the number of carbons attached to this carbon. Do you follow me?
Okay, I got it.
You got it now? That's it. So this is secondary. That's it. Now, what's the classification of this carbon, the last one? That's it. Then what are the type of carbons we have in this compound? We have 3 primaries. Do you follow me? We have 1 secondary. We have what?
Tertiary.
1 tertiary. This is regarding the carbons. Now, if you want to extend the question, what are the hydrogens we have in this structure? We have, as we said, the classification of hydrogens is the same or following the same classification of the carbon attached to. You follow me? This carbon is a primary. It has 3 hydrogens attached to it, isn't it?
Yeah.
So that means these hydrogens are the 3 hydrogens here are primary. So we have 3 primary, 3 primary, 3 primary. The total are 9 primary. We have,
I have understood this point.
I'm sorry?
I have understood this point. Thank you.
Wonderful, perfect. Any other question about the classification of the carbon atoms? Because as I said, this classification is a straightforward issue, but we need it just to simplify our study, to simplify the studying of organic chemistry. All right, okay, so let's talk about the nomenclature. Now, from now on, you have to remember this. In any chapter, because the whole study of organic chemistry is systematic, we always do the same. In any chapter, we study a chapter of certain functional group. The first thing we study in this functional group, we study the nomenclature, the rules for giving names of these compounds having this functional group. And after that, of course, we will study reactivity, the reactions, the physical properties, and so on and so forth in each chapter. So this is the same, we will repeat it, which is the nomenclature or naming of alkanes. We will, whenever we study, for example, alcohol functional group, we'll have always a section for naming of alcohols. If we study alkene, we have naming of alkenes, and so on and so forth. Naming of alkanes. The naming of alkanes based on a committee, a scientific community or committee, we name it or we know it as IUPAC nomenclature or IUPAC community of giving the names or scientific names. What's the IUPAC stands for? I stands for international, U stands for union, and P stands for pure, A stands for applied, and C stands again for sure, it stands for chemistry. This is international scientific committee all over the world, which called International Union of Pure and Applied Chemistry. So this is the community or the committee which is responsible to put the rules, and the rules in here, we are using these rules for one purpose, and this is the main purpose of following the rules here, is that every organic compound must have a unique name. So the motto for IUPAC that every organic compound must have a unique name, IUPAC name. In other words, there are chemists in Oman, there are chemists in America, there are chemists in Germany, there are chemists all over the world. In all over the world, no two chemists should give two different names for the same compound. Compounds, or every compound must have only one single name based on the rules. So if we follow all chemists all over the world, if we follow the rules, we must achieve only one unique single name of the compound. Do you follow me? So that's actually the motto in here. And the rules in here actually for the impact nomenclature, the rules here always there are certain pattern for the giving the name of any organic compound, if it is alkane or anything else. First, there will be always prefixes, and there will be then location or locant, location of the substituent. Then there will be parent, and there will be suffix. The suffix here always is indication for the functional group. For each functional group, there is always a suffix for this functional group. All right? The parent here is always related to number of longest or number of carbon atoms in the longest chain. Number of carbon atoms in the longest chain. It's very, very important actually this here, because always the most important aspect for giving the IPAC name is simply determining the parent. And the parent, it depends on the table what I asked you to remember or to memorize in the previous lecture. For example, if we have decided, based on the rules, that the longest continuous chain of carbons is 9 carbons. 9. So what should be the parent then? What do you think? What should be the parent? Any trial? Anyone would like to answer? Right, but what's the name? What's the name of 9 carbons? Exactly, like no name. So no name here is the parent here. Known is related to the known carbon 9, and N here is relating to, that's actually the suffix which we use it for alkane. So nonane is the parent name for alkane with 9 carbons. Do you follow me? Anyway, the location, there should be always the location of the substituent in here. All right? And the prefix in here, we will see all of this actually based on the rules or while we are studying the rules. But as I said, the parent is always the most important thing because it is connected to the longest continuous chain of carbon atoms in any compound. So always the first rule for the IPAC nomenclature of alkanes, we must determine the longest continuous chain of carbon atoms. These words are very important. So we must determine longest continuous chain of carbon atoms. Please do not rely on what I'm writing on the board, because I am writing on the board just like abbreviation, just for the sake of not wasting time. So the most important thing, just the rules are actually explained in details in the slides and the book, so you can just follow up them nicely. But we are just discussing these rules. The first and important rule, the most important rule here is this rule. We must determine longest continuous chain of carbon atoms. So the longest continuous chain of carbon atoms, which means the carbon are connected to each other. We have to go in one direction. That's the meaning of the continuity of the longest chain of the carbon atoms. And in this case, as soon as we determine it, and the parent name will be the corresponding alkane name. Again, if we determine that the longest continuous chain of carbon atoms is 5, that means the parent name in here is pentane. So if we have the longest chain is 5, that means we have the parent name as pentane. The pent is the parent name, and the ane is the suffix actually which we use to indicate the alkane. Is that clear?
Doctor, they have no picture.
Some of you have no picture, but the others, do you all have no picture, or some of you have no picture?
No, for me I can see you.
So then that cannot be actually, some of you can see me, others can't.
I don't know.
Right? I don't know how things can happen like that. Maybe they have some internet problem. Who cannot see the picture? If anyone cannot see the picture, it's very simple. You can just log out and then log in. I'm pretty sure it will work again. Right? Okay, anyway. So this is the first rule. As I said, we must determine the longest continuous chain of the carbon atoms in the compound. Okay, so let's just take example for this. An example, let's say we have CH3, CH, CH3, CH2, CH3, CH2, CH2, CH3. What's the longest continuous chain of carbon atoms in this example? How many carbons should be the longest number of carbons?
5.
5. Which is this, you mean? This is the number of carbons. This is the chain, isn't it? Right? Yes, some of you wrote 6, which is true. Actually, the 6 is the longest continuous chain of carbon atoms. This is simply, we have like 5 if you choose in the A chain or B chain. B is the longest chain of carbon atoms, while A is not the longest. So A is 5 carbons, but B is 6 carbons. So then definitely B is the correct one, not A. Is that clear? So we always must find longest continuous chain of carbon atoms. In this case, the parent name of this compound must be hexane. You follow me? The second rule in here, is that clear for this? So the longest chain, not necessarily to be straight like that. It must be only longest continuous. In other words, you must just go into during or through the chain in one direction only. In other words, here, this is chain 1, following, this is a chain. This carbon connected to this, then connected to this, connected to this, connected to this. Then this is a continuous chain of carbon atoms. Yes, you have a question? An example of what? Example of another example of longest chain? Yeah, non-continuous chain. I see. For example, here you cannot, in other words, you cannot consider, let's say, non-continuous chain. All right. Let me just give you another example. CH3, CH2, CH. CH2, CH3, I really have no idea. CH2, CH2, CH. 2CH3 then suppose just C, this is not CH, CH2 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 CH3. So another example, I don't know if there will be any continuous chain or not, but just looking for that. Now, okay, all right. So what we mean by longest chain, let's take this example. What's the longest chain of carbon atoms we have in this example? How many carbons?
20.
How many carbons? 9, you mean? So it is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, this is true. This is the longest chain of carbon atoms. But we cannot consider, for example, 9 and also this. And also these 3, for example. To consider 12 as the longest continuous chain of carbon atoms. Is that clear about it must be continuous? Why we cannot consider these 3 as part of the longest chain? Because as if this is the direction of the chain, then we can move another direction, which is not true. You have to move into a chain in one direction only. You cannot go or change the direction of the chain. Is that clear? Is that clear about continuous or non-continuous? So if you consider this as the longest chain, this is wrong because this is not continuous. Although it will be longer, it's not true. Because the correct choice here, we must always choose longest continuous chain of carbon atoms. أحمد العجمي انقطع الاتصال عندك. As I said, if you cannot see it for any reason or the picture has been disappeared, you just log out, log in again. That's actually maybe the problem. I don't know really what's wrong with this. This is a technical problem, maybe by Google, but by all means, if some of you can see the picture, then definitely it's an internet problem. It's not anything else. That's a very good question, Shayma. Very, very nice question. The question of Shayma, what if there is another atom, not only, carbon? We don't consider now. We only, the parent name, always related to longest continuous chain of carbon atoms. Now, if there is another atoms, we will come to that. We'll come to that when we discuss or deal with another functional groups. These atoms will affect the suffix of which we are adding to the parent name. In other words, the ending of the parent name, what it will be. But it will not has anything to do with the longest continuous chain of carbon atoms. Is that clear, Shayma? So only focus on the number of carbons, not any other atom. Yes, please.
It doesn't matter what atom is connected to the carbon?
I don't get your question actually.
So what if there is another atom rather than nitrogen connected with carbon atom?
We don't. We will discuss. We'll come to that actually when we discuss, for example, another functional groups. But now we are discussing alkanes. Alkanes has no other atoms now for the time being. Do you follow me? Now we just focus on the longest chain of carbon atoms. Do you follow? So we don't. If there is any other atoms, it doesn't affect the longest chain. So we just consider it as the longest chain. Do you follow me? Because in this chapter we are not going to deal with any functional group rather than alkane. In the coming chapters, definitely we will deal with another nomenclature which has another functional group such as another atoms and so on and so forth. Got it? Just focus now with me for the basics of the nomenclature of alkanes. All right, so I hope the first rule is clear. So, but just to add to the first rule, regarding the choice of longest continuous chain of carbon atoms, if there is, so let's say this is second rule, if there is two or more longest chain with same length, here, all right, we must choose the one which has more number of let's say branches, or sometimes we call it substituent. This is a very important rule regarding the choice of the longest chain of carbon atoms. In some cases, we may have or we may find more than one longest chain of carbon atoms. In this case, with the same equivalent, with the same length. In this case, we must choose the chain which contains more branches or more substituents. I think with example this can be more clear. Let me just see. So we have CH3, CH, CH2, CH2, CH3, CH. Don't write it now, just let me find out the appropriate example. So, all right, okay, CH2, CH3. All right, this example, can you see it well? Do you all see this example well? Okay, so let's see what are the longest, or where is the longest continuous chain of carbon atoms? Or what's the longest continuous chain of carbon atoms? I need answers. I'm just waiting for your answers. How many? How many?
All of them. 7.
7, but what are they? We have one option is this straightforward one, isn't it? So let's say this is A, right? So this is A chain. Is there, first of all, and what else, what other chain or what other possibility? This could be this one. So this is B chain, isn't it? Right? So as you can see, A is 7, B is again 7. Now, if they are the same, anyone is fine. Like if they are different, then you must remember what we have said before. That in this case, if there is 2 or more chains with the same number of carbons, then we must choose, or our parent name then, or our, let's say, longest chain then, it will be the chain which contains more number of substituent or branches. Now, in A here, as you can see, what you will see, how many branches we have on A? We have only one branch on A. So A attached to only one branch. But B, how many branches are attached to B? 2, exactly. B are attached to 2 branches. We have this, and then we have this. So B is attached to 2 branches. So which, then definitely here it's not a choice. This is not, the privilege of a choice that you can choose this or that. Then here A is wrong. It's not accepted. If you choose A for any reason, the whole your work will be false, and the whole name will be false. Do you follow me? So that's actually the case here. The B is the longest continuous chain of carbon atoms. This is very important, and it is extremely important to focus on this. Is there any question about it? Any question, guys?
Victor, can you repeat?
Okay, the one who asked actually, did you get the previous rule, what we said? In case we have 2 chains or more with the same length, then we must choose the longest chain which contains more number of branches. That's the rule here. You follow me? In this example, I will repeat it, of course. In this example, A here, or this chain, contains 7 carbons. This chain, B chain, contains again 7 carbons. The difference between these two, that A chain has or connected to 1 branch. Do you see? Because this is like, it's not part of the chain. So that we have only 1 branch. Do you follow me? While B here, معاي؟ I'll come to your question, Shayma, when I finish this. While B here, you can see here, B, we have, which are the branches which are not part of the chain? We have this and that. So that means B is attached to 2 branches, while A is attached to only 1 branches. Therefore, B is the correct one, A is not correct. Clear?
Yes, Victor, clear.
Sure. بالنسبة لسؤال سلمى, what if the number of carbons are the same and the number of branches are the same? It means both are, anyone is correct. Yani either this or that are the same. There will be no change. But you will get the same name then. Everyone will get the same name then. Alright? The most important thing, just take this into consideration, that after we apply the rule and we found the longest continuous chain of carbon atoms, then we must find, we must see if our longest chain is also having or connected to more branches, because that's then the case in this case. Now, let's just continue in this example and then go forward to the rules here. So the next rule, after we have decided, after we found the longest continuous chain of carbon atoms, then what we need to do, we need to number the chain in order to find out and to name the branches, because the chain, longest chain, it's just the name of the parent, but we need to name everything in this compound. So I'm just redrawing or just making it more clear. So we have CH3 here, CH2, CH2, CH, CH2, CH3. All right, so we have decided that this is the longest chain of the compound. Now, after that, we must now rule number 3, let's say, number the chain to have, or closer to the nearest branch. Do you follow me? All right. Now, we have طبعا the chain what we have chosen is this chain, right? So this is a chain. We have only two options for numbering the chain. Either we start from this side, going this way, or we're going upward, opposite way. Mafi, there is no other choice. So according to the rule here, we must number the chain closer to what? The nearest branch, or closer to the first branch. CH2, 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 CH3. In this case, I must number the chain from this side. 1, 2, in order to get this branch, the lowest possible number. So I give it 2 and then continue 3. I will give also this 3, then 4, 5, 6, 7. Is that clear? It's extremely important. By the way, I'm just going slow through these rules because these rules are the foundation of all IUPAC nomenclature, of all functional groups. These rules, they will be in every chapter. You must use them all the time. So therefore, it's extremely important to understand them today, because otherwise, the next chapters will be just addition to that. That's it. You will be just a master of finding the IUPAC name of any organic compound. Do you follow me? But these are foundation, as I said. It must be here. We must number the chain closer to the nearest branch. Actually, there is a logic here for the IUPAC. And the logic in this, for IUPAC, that IUPAC always try to give the branches the lowest possible numbers by the rules. So in this case, as you can see, according to this rule, we will give the branch here number 2, which is the lowest possible number. If you proceed opposite way, لو افترضنا, if someone choosing to start the numbering from this side, what's gonna happen? هيكون 1, 2, 3, 4, 5, 6, then 7. What's going to happen that he will give the first branch at position number 5, and then the second branch will be at position number 6, which is opposing the, let's say, the logic of the IUPAC. That the IUPAC always follow this logic, that substituents or branches should be given lowest possible number by the rule, always. Is that clear? Is there any question about this rule, about numbering the chain closer to the branches? Mahallab, I don't understand your comment. Clear, okay. All right, I got it now. Maria, what's the not clear, Maria? Ask about what you want, what you don't understand. Is there any question about it? All right, perfect. Okay, so after we have chosen the longest chain of carbon atoms, after we have numbered the chain according to the rule, then now we need to put the full name, and then we need to give the full name of the compound. Again, I need to erase all of this just to make the structure. I'm sorry, I just need to redraw the structure. So we'll have CH3, CH2, CH3, then CH3. I'm sorry, this is C. Right? Oh no, CH. Then CH2, CH, I think 1, 2, 3, 4, 5. CH2, CH3, 1, 2, 3, 4, 5, 6, 7. Yeah, right. Okay, so this was our example after we applied the first and the longest chain rule and the number of the chain. So we'll end up with this 1, 2, 3, 4, 5, 6, 7. In this case, we have to give, so what we have, what's the name of this branch, guys? What's the name of this branch? What we call this branch? Or this substituent, what we call it?
Primary.
Primary is a classification, is a general classification. It's not the name of the alkyl group. Huh?
Methyl.
Methyl. Bushra, be very careful. It will never be methane, will be only methyl. Methane is CH4. We're talking about alkane minus hydrogen, so it will never be methane. So this is methyl. What else? What's the name of this alkyl group, guys? Ethyl, exactly. Exactly, Maria. So this is ethyl. So we have these two branches. We must then now give the name of every branch, every. Just put few lines under every word. We must give the name of every branch preceded by their number, yani the number and the name of every branch in this compound. We start them with them. So the full name will be, actually in this case, will be 3-ethyl, then 2-methyl, then the longest iconentity, heptane. Do you follow me? Now let's just write for or comment or more punctuation rules actually for the epoch nomenclature. In this case, as you can see what I have written in here, I have list the branch first, the one which has actually more alphabetic priority. So the E before the M here. Can you see it? I didn't change their numbers. I only list them here in the name. We list the substituent based on their alphabetic priority. So the E before the M. That's an important issue. But keep in mind that we didn't change the numbers. The numbers, we just these the numbers based on the rules here. Do you follow me? So this is the first punctuation rule. Do you follow? So the first punctuation rule that we list all branches based on their alphabetic priority. The one which has more alphabetic priority must be listed first, and accordingly the other branches. Do you follow me, guys? Is that clear? All right. This is the first punctuation rule. The second, always use a hyphen between any number and letter. Between any number and the letter, we must use a hyphen. It's not, a luxury issue that we sometimes use it, we sometimes don't. These are rules, guys. We must fulfill them perfectly and precisely. You follow me? So we must use hyphen always, regardless of what's the name, between any number, whatever number you have, and a letter. Da'iman, this is true. Secondly, there is, at the end of the day here, between this letter and letter, this is L and this is H, no space between any two letters. Do you follow me? These are very, very important issues, and these are actually how we do it as a punctuation rule. There are, of course, many more rules and so on and so forth, but I'm just highlighting the major important rules for the nomenclature of alkanes in order to help you practice actually for the nomenclature and so on and so forth. Do you follow me? Is there any question about what we have discussed so far before I erase? Yes, please. Go ahead.
Should we write dimethyl?
Dimethyl, why you should write dimethyl?
Because we have two CH3
Where are they?
in 2, yeah?
This is one, this is methyl, right? Where is the other methyl you have?
Next to him.
This one?
Yes.
No, this one is part of the chain. It's not a branch, isn't it?
You have.
Right? So this is only we have a methyl here, but this is not part of the. This is not a branch. It's just part of the chain. And that's why actually, this is very important question actually, because as I said, these questions what will make you understand the topic. You follow me? Now, we're done with the chain. خلاص عرفنا الchain احنا. Chain هو بكل بساطة the longest chain هو heptane. Done, isn't it?
Okay.
And what left here is this, the branches or these two branches or substituents. So that's why we need to also give their names as alkyl groups and their numbers. Do you follow me?
Yes.
Perfect. Any other question? Any other question? Please guys, don't hesitate to ask, because you know these questions actually what will make you understand the topic. Even whatever the question is you have in your mind, never ever hesitate to ask, because as I said, everything actually is written in your PowerPoint presentation or in the book in a very nice, wonderful, fancy way. But to understand it, you need to ask questions. You need to, think. You need to make a logic in your brain. Does it make a logic or not? If not, then ask. Do you follow me, guys? So please, never ever hesitate to ask questions. As I said, there are also more and more, extensions of the rules. But what we have discussed now are the major rules which enables you, when you go at home, read again the rules and simply start to practice to fulfill the rules. Now, there is another extension of the rules. If the same substituents are there, if more than one same type of branch of substituents, use di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, and so on and so forth. Do you follow me? So use these Latin numbers to indicate the number of branches which are repeated in a molecule. Do you follow me? Remember a very important rule. Every branch must be designated by a number. It's very important. Let's keep these in mind and then take another, let's say, more complex question. Let me just give you another example. Suppose we have CH3, C, CH3, CH3, CH2, CH, CH3, then CH3. Alright? So, what's the longest continuous chain of carbon atoms, guys? of this example. What's the longest continuous chain of carbon atoms? 5, exactly. Let's take it for easy point of view, it will be this. Because regardless of where you take it, this way, it's always the same number of branches, so it's the same. So here, in this case, we have decided the longest chain to be 5, so then we need to number this chain. Either we number it from this side or from this side. If you number it from the right, let me just put two options. I will write it from the right. 1, 2, 3, 4, 5. If you write it from the left, or if you, number it from the left, you're gonna get 1, 2, 3, 4, 5. Which numbers or which numbering is the correct one? Sometimes they are both the same, sometimes they are totally different. I mean, one will be correct, one will be wrong. Because as I said, science is all about precision and accuracy. We must be precise and we must be accurate. Alright? So which number is correct and why? Which numbering is correct? The left side is more accurate. Why? Why, Fatima, the left side numbering is the correct one?
Because it has twice two branches.
What does that
The
mean?
nearest branches.
True. If you follow the left side numbering, what we are going to get as numbers of branches, we are going to get 2, 2, and please take care of your mics, guys. If you leave your mic on, everyone will hear you, and we can hear you. Anyway, now this is left numbering. If we number the chain from the left, the numbers of the branches we are going to give 2, 2, because we have 2 branches here at position 2, and we have 4. But the right numbering, we will get 2 for only this, and we'll get 4, 4. Which numbers or which set of numbers for the branches based on the ABAC will be true? The 224 or 244? Which one? 244, 224, and because simply, again here, it's just, remember, that's why actually I'm asking you just to focus on very simple issues to understand them. I said from the beginning, I kept repeating it, there is a logic in here for the AIPAC nomenclature that we must, or the AIPAC try to give the branches the lowest possible number. Here, 2 to 4, we are giving more branches lowest possible number compared to this. Therefore, this is correct, this is wrong. Do you follow me? We must agree on this. That how you do this, you just compare. You just compare. Here, the first branch, you give it 2. This is 2. The same. This is 2, but this is 4. Then definitely this is true, this is wrong. That's it. I stop comparing them. Do you follow me? So that's actually how you choose the correct way of numbering of the chain, that we always keep this in mind. We give the branches the lowest possible number. Do you follow me? In this case here, what would be the name? The name here, we will use all punctuation rules in this case. Here, I'm just going to write it right away. We will have 2, 2, then 4, then tri, methyl, then pentane. Do you follow me? Please give some attention to the punctuation rule again. What you have seen here, we always use a comma between any two numbers. A number and the number, there must be separated by a comma, and between any number and the letter there must be separated by a hyphen. And then we use try for 3 methyls pentane. Do you follow me? You have some knowledge, maybe previous knowledge from school about the epoch nomenclature of alkanes and so on, but this section actually is extremely important, because if you understand nicely the epoch nomenclature of alkanes, believe me, you will face no difficulty at all for the nomenclature of the coming chapters. Selma, what's your question exactly? I didn't get it. How you want to consider the chain? What's the other way you want to consider the chain? Starting from 4. Okay, Selma, okay, what you will end up with. So Selma is suggesting that, okay, I'm just going to follow the suggestion of Selma. Selma wants me to start from carbon number 4. CH3, and then here CH2. Okay, so you want to start from here and then going where? It's okay, Salma, no worries. I'm just following with you. It's fine actually. That's because it's your question again is very important, Salma, because if you have another choice, you know, for the same chain which is better, then definitely there's only one choice which is correct. The others are different, are wrong. But sometimes, as I said, whatever you look at it, the chain, you will end up with only one choice, or it's the same, then khalas, anyone will be the same. You follow me? Okay, I got your question. Chapter carbon 3, okay? Okay, sorry, Salma Salma still have a question. Okay. Salma, can you speak up maybe easier, you know, just to understand your question? Anyway, if Salma cannot speak up now, if we cannot wait longer, but anyway, just think about it, guys. As I said from the beginning, organic chemistry is a collection of small piece of information, small, easy piece of information. In order to make the whole issue, it's all right, Salma. You can, if you didn't, just check it again, just practice, and if there is any further question, you just contact me by email. I'm just going to end up the lecture by saying this, and I always repeating that. Guys, organic chemistry is a collection of small piece of information. Small, simple piece of information. If you practice from the beginning, one by one, and so on, day by day, and so on and so forth, then slowly you will become mastering organic chemistry, and you'll see it a piece of cake actually topic, and you will enjoy the topic nicely. Otherwise, if you choose not to practice, if you choose not to solve problems, unfortunately things becoming more and more complicated and more difficult. All right, I think I will stop the lecture today at this point. And next lecture, inshallah, we'll continue chapter 3. I urge you all guys to practice at home and to solve as many nomenclature problems as you can. This is the time to practice all problems at the end chapter in order, and you should never have any problem if you follow the rules, what we have discussed and what we have said. I wish you all guys a very pleasant and good day, and see you inshallah next Monday. Thank you.